Hello everyone, let's study about the classification of waves. Waves can be classified based on dimensions along which the wave propagates, based on medium of propagation, and based on the direction of propagation of energy. Let's look at one by one. The first type is based on dimensions. Now, based on dimensions, there are three categories called as one-dimensional waves, two-dimensional waves, and then three-dimensional waves. As the name tells us, one-dimensional waves means these are waves which travel in one dimension or along a straight line. Now, one dimension basically means a straight line motion only. So, if the waves travel only along one dimensions, then those are called as one-dimensional waves, or in short, it's called as 1D waves. Examples of these are when the string of a sonometer wire. Sonometer is a device. When the string of a sonometer wire or any musical instrument is plucked, then the waves travel along a straight line are produced. For example, as seen here, this is like a straight wire. What you can see is a straight wire here. Suppose in this case, somewhere, if it is disturbed, then since the two ends are confined, the waves cannot be progressive wave. Rather, what we get here is only one-dimensional waves. Energy or momentum is confined only in one dimensions. So these kind of waves called as one-dimensional waves. Here, what we get is called as standing waves, but even this is nothing but example of one-dimensional wave. This is called as a sonometer. Sonometer basically consists of an arrangement where there are two knife edges on which wire passes and some weight is attached onto the wire. Now suppose somewhere here, if we place a tuning fork, then this would induce some waves onto this wire. Even here, the waves on this wire would be a one-dimensional wave. Next type, which is based on dimensions, is called as two-dimensional waves or plane waves. As the name tells us, these are waves in which the energy or momentum is confined or travels in two dimensions. Examples of these are ripples formed on the water surface. We know that the water surface is a two-dimensional plane. If water doesn't leave the surface, then the waves produced would move only on the water surface. Those are called as two-dimensional waves. Example is given here. In this case, if a disturbance is produced somewhere on a lake or water surface, energy moves in all directions, but energy moves only on the water surface. It doesn't leave the water surface. In such case, this kind of waves are called as two-dimensional waves. So wherever the energy or momentum is confined to a plane, then it is called as a two-dimensional waves. The third type is called as three-dimensional waves or spatial waves. Now, as the name tells us, three-dimensional waves are those waves in which energy or momentum, or in simple language, the waves moves three dimensions. Examples of these are light waves. For example, assume that there is a source of bulb, like bulb in a room. Now, if the bulb is turned on, the energy goes in all directions. It is not confined to a given direction, it goes in all directions. The entire room is illuminated, which means the energy goes in all three dimensions. Such waves are called as three-dimensional waves. Examples are light waves or electromagnetic waves. In fact, the energy from sun also is an example of three-dimensional wave only. So based on dimensions, we have one-dimensional wave, two-dimensional waves, or three-dimensional waves. The second classification is based on medium of propagation. Now based on this, there are two kinds of waves called as mechanical waves and then non-mechanical waves. Now let us see what these waves are. The first type called as mechanical waves. Mechanical waves are those waves which require the existence or presence of a medium for the propagation. Now there are certain waves which require a medium for propagation. Those are called as mechanical waves. Examples of these are sound waves, earthquake waves, water waves, etc. In fact, many waves are examples of mechanical waves only. As given here, imagine that there are two sources, like two speakers here, and then when they produce a sound, then this sound requires a medium, which is air, for its propagation. Remember the experiment done in school, the experiment which is called as bell jar experiment, where if the bell is placed in a vacuum or if the bell is placed in a glass chamber and if air is removed from it, then sound can't be heard. So an important condition for sound wave to propagate is presence of a medium. This could be solid, liquid, or gas also, but what we need is a medium. So sound waves is an example of mechanical wave. Even here also water wave is very obvious. Water waves even require presence of the water obviously. And also in case of a spring, if we compress or expand or let it oscillate, for example, if you take a spring attached to weight, let it oscillate, it may oscillate. So even here, if a wave is produced, even that wave also requires presence of medium to propagate. So these kind of waves are called as mechanical waves. An example here is also given about earthquake waves. For example, suppose imagine earthquake strikes here. This is epicenter from which a disturbance is produced. Then the waves goes in all directions. So the waves travel to the material. Even this is example of a mechanical wave. The next type is the non-mechanical waves. So as the name tells us, these are waves which doesn't require, which means these waves can propagate even in vacuum or free space. Those are called as non-mechanical waves. Examples of these are electromagnetic waves. Examples or types or kinds of electromagnetic waves are light waves, gamma rays, X-rays, UV radiation. All this are nothing but part of the electromagnetic spectrum. So those waves which doesn't require a medium for propagation are called as electromagnetic waves. The third classification is based on the direction of propagation of wave. Based on that, there are two types called as transverse waves. The second type is called as longitudinal waves. Let's study them one by one. Transverse wave is defined as a wave in which the particles of the medium vibrate in a direction perpendicular, this is very important, to the direction of propagation of wave. Understand this, recall that in case of waves only energy and momentum is transferred, but the particles or matter doesn't move. But how does energy and momentum be transported? To understand this, we can think that a medium contains a lot of particles. So these particles will vibrate or oscillate. Now each particle will vibrate about its mean position. It vibrates like this. Every particle is vibrating about its mean position. and then they exchange energy. So in case of transverse waves, if the particles oscillate in a direction which is perpendicular, if the energy moves in this direction or if the wave moves in this direction, let's call the speed as v. If the speed of wave is v, if it moves in one direction and if the particle oscillates in another direction, in this case the particles are vibrating perpendicular to the direction of propagation of wave. Such waves are called as transverse wave. As seen here, the particles are oscillating. So particle from here will vibrate between these 2 points. You can think of this string or the wire to contain a lot of particles. So each particle in the wire would oscillate about its mean position. This particle has come down here. This is somewhere here. The particle is gone somewhere here. So every particle will go to the extreme ends and come back to the other extreme end and then to the mean position. So in such cases, particles are vibrating perpendicular to the direction of propagation of wave. Then such waves are called as transverse wave. To remember this, you can look at the letter as T. Think of the letter T. You can think of this sign. This sign gives the direction of wave propagation, and this line indicates the direction of motion of the particles. So transverse waves are examples of, or light waves are examples of transverse wave. There are many examples. So one example is electromagnetic wave. Other examples could be waves produced in a stretched string. For example, we saw earlier that if you have stretched string and then if it is somewhere plucked or disturbed, then what we get is standing waves. In this case, standing waves are produced. But even here also, if the energy moves from say left to right, in this case the particles will oscillate or vibrate in direction which is normal to its propagation. They are called as transverse waves. Now in transverse waves, we saw that the particles will oscillate about their mean position. In this case, if this is their mean position, every particle will oscillate to its extreme position. It will go to this position and to this position. Apparently, the particle from here has gone to the extreme position. It's gone till here. The particle from here has gone to this position. It will go up and come down, which means every particle will oscillate between the extreme positions. At this moment, the particles from here and here has gone to the highest positions. Particles from here and here have come to the lowest position. But later, this will go up and will go to the extreme position. So in such cases, the highest displacement, which is positive, is called as crest, and the lowest displacement is called as trough. So keep in mind that in case of transverse wave, what we get is crests and then troughs. The distance between any two crests or troughs is called as wavelength. We will study it in detail later. So keep in mind that the distance between two crests or two troughs is called as a wavelength. The last point for transverse waves is that transverse waves are propagated only in case of solids and liquids. This is a very, very important property. Next type is called as longitudinal waves. So in case of transverse wave, if energy was propagating in one direction, the particles were vibrating perpendicular to its direction. It's called as transverse wave. In this case of longitudinal waves, energy moves in one direction, even the particles will also vibrate or oscillate along the same direction. We can say that these are waves in which energy is propagated in the same direction as that of the particles of the medium. Examples of these are sound waves. So in case of transverse wave, we had crest and then trough. In case of longitudinal waves, we have something called as compressions and rarefactions. So if we look at the air molecules, because an example of longitudinal wave is sound waves. If we look at air molecules, these will oscillate. So at some point, what we find is we find a region where there will be more particles like this. We find more particles in a region and slightly spread away, and then more particles in a given region, and then spread away, and then more particles like this. So these regions which contains more particles is called as compression. Center of it is compression. And the center of the minimum particles is called as rarefactions. We will study it in detail in later topics. For now, keep in mind that in case of longitudinal waves, we get compressions or rarefactions. And unlike transverse wave, longitudinal waves are propagated through solids, liquids, and gases. As given here, these regions where you find higher density of particles is called as compression. In the region here where it is minimum density is called as rarefaction, or as given here, the region where you find high density or concentration of the net is called as compression, and the low density is called as rarefaction.